Hi, welcome to this lesson on Euclidean geometry, circle theorems, the center to chord and converse theorems. Let's have a look at question 1. In the circle with center O, we have that the radius is equal to 10 units, OQ is perpendicular to PR, and PR is 8 units. Determine the value of x. So let's look at the information we were given. We were given the center of the circle. That is really important, because to use the center and chord theorems, we need a center and a chord, as the name suggests. We were also told that this line OQ, so from the center to this point Q, is perpendicular to this line PR. The line PR is a chord of the circle, because it is a straight line connected by 2 points on the circumference of the circle. So we were given that it is perpendicular. So now we can use the first theorem that says a perpendicular line, OQ, from the center of a circle to a chord bisects the chord. So therefore that means the length of PQ must equal the length of QR. But we were given the length of the total chord PR as 8 units. So therefore half of that means that this must be 4 units and this must be 4 units. Lastly, we were given the radius length of 10. So if I construct two radii lines from O, the center, to the endpoints of the chord PR, then these are also 10 units long, because all radii are equal. Okay, so remember the radius is any line from the center of the circle to the circumference of the circle. So now we can see in triangle PQR, or PQO, we have a right angle triangle with the length OQ equals x, the length PQ equals 4, and the length OP equals 10. So we can use the Pythagorean theorem here, because it's a right angle triangle, to work out the value of OQ. Okay, so I'm going to write this very formally so you can get an idea of how to start structuring your proof writing when it comes to geometry. So the first thing I will do is that I'll say, this is my given information. I was given center O on the circle. I was given a radius line of 10 units. So I'll call that little r. I was given that OQ is perpendicular to PR. And I was given that PR equals 8 units. So I need to make sure that when I'm answering any geometry question, I'm ticking off every single piece of information and making sure that I've utilized it. Because 99.9% of the times when we get stuck in any type of problem, it's because we are either withheld information or we are not using all the information. Okay, so what am I going to do? So the first thing I said, so firstly, we have that OQ bisects PR, and the reasoning for this is that OQ is perpendicular to PR and O is a center, or is the center of the circle. So that is by the first theorem there. So I've used the fact that we've used the center, I've used the fact that these are perpendicular, and I therefore have concluded that OQ bisects PR. So therefore, this means that PQ equals QR, because it bisects, because OQ bisects PR. So therefore, I know that PQ plus QR must equal PR, which is 8 units. Again, that was given to me. But these are the same length as we saw. So if I call them x, I have x plus x equals 8, which implies that 2x equals 8, which implies that x equals 4 units. So therefore, PQ equals QR equals 4 units each. Okay, then I'm going to say triangle PQO is a right-angled triangle. Therefore, by Pythag, so the Pythagorean theorem, we have 4 squared plus x squared equals 10 squared. So I have x squared plus 16 equals 100. I take over the 16 by subtracting it, and I'm left with x squared equals 84. Okay, and then I take the square root on both sides. But now let's think about this really carefully. This is the length of a triangle. So we do not look at the negative square root part, we look at the positive square root part only. So the root of 84, if we wanted to work that out, is simplified to 2 times the root of 21 units. Okay, and that is the length of x in this question. So we had to make sure that we understood all the given information. So we used all the given information. We then were able to logically, in logical steps, tell us exactly what we were doing and the reasoning behind it. So this is the sort of basis of geometrical proofs. Everything that you write and claim must have a reasoning behind it. Some texts will often give you what they call the tabular method of proof writing, and that is you give your claim here and you give your reasoning here. So for example, if you wanted to say that PQ equals QR, that would be your claim, and then your reasoning is that OQ bisects PR, as an example. Okay, so if you want to do the tabular method of proof writing, that's perfectly fine as well. But if you just want to list it out in a normal way of writing, that is also perfectly fine. Okay, as long as what you're writing makes logical sense. That is what we are looking for when we write proofs, just to make logical sense. Okay, I'll see you in the next one.